In this session, we shall take a look at open circuits. We shall understand the concept and look at some troubleshooting tips that will help us deal with open circuits. What is an open circuit? Well, assume we have 2 points A and B on a circuit. If point A is not directly connected to point B, then we say there exists an open between point A and point B. By directly connected, we mean using some sort of conductor, or maybe there exists a component in between. We can outline 3 key properties of an open circuit. First of all, there is no connection between the 2 points. Because of that, the resistance across the open points is infinite. If the circuit does have a voltage supply, then the voltage across the open points will equal to the supply voltage. This doesn't necessarily mean the main supply voltage. It means the supply voltage supplying that part of the circuit. Well, let's look at the proof. Ohm's law, voltage is current times resistance. Because R is very, very large, therefore V is I times infinity. We can't have infinite voltage, so the voltage will equal to the supply voltage. Okay, so now we have a diagram of a switch that's open and a switch that's closed. From the schematic symbol, we can clearly see there is no connection between point A and B, but there is a connection on switch 2 between point C and D because the switch is closed. If we look at these components, on the surface from the schematic, we see there's a connection between point A and B. Here we have an inductor, here we have a resistor, and here we have some device. But in actuality, we cannot always tell that there exists an open between 2 points just by a visual inspection. So therefore, we do need our instruments. We'll start with a series circuit and we'll set up a couple of scenarios and we'll use our instruments to troubleshoot the circuit. In other words, we'd like to determine whether an open exists in any of the components. Taking a look at this circuit, what do you think the voltage across this switch will be? That would be a good time to pause the video. That's right. So it is close to the supply voltage, and we're measuring 11.915 volts using the voltmeter. So this verifies one of the properties which we had listed before, that the voltage across the open is equal to the supply voltage. What voltage can we expect across the switch if it's closed? Well, according to Ohm's law, if it's closed, the resistance will be 0, so we should expect 0 volts. Putting our voltmeter across the switch, you see, using multi-sim, we're measuring 0 volts, that's 0.018 microvolts, which you must interpret as 0 volts. Let us see if we can identify if any problem exists in the circuit below. Remember, this is a series circuit. Well, the properties of a series circuit are we have a single current path, the current is the same throughout the circuit. The total resistance is the sum of R1 plus R2 plus R3. The total voltage should be the sum of the voltage drops across each of the components in the circuit. Let's start with the power supply. We have a 12 volt DC supply voltage, and we're measuring 12 volts across that. So we know that's good. We're measuring 0 volts across the switch. That tells us that the switch is closed. If we look at the voltages, we have 4.6, 5.5, and about 1.8. And if we add these volts together, we get 12 volts. So there is no problem with this circuit. Let's look at this scenario. We'd like to identify the problem, if any, that exists in this circuit. Again, we'll start with the supply voltage. We're measuring 12 volts, that's good. We're checking our switch, it's closed. We're measuring 0 volts across the switch, because if the switch is open, there will get no current flowing through. So under normal circumstances, we should expect current flowing through. Resistor 1, we're measuring, that's 0.012, so in effect that's about 0 volts. Resistor 2 is 0.036, that's also 0 volts. And resistor 3, we're measuring 11.9, which is close to the supply voltage. If we recall, the voltage across an open is approximately equal to the supply voltage. This tells us resistor 3 is open. We've added a fuse to the circuit, and would like to identify whether the problem exists with the fuse. Some fuses, by visual inspection, we can tell whether it's good or bad, but other fuses we cannot tell by simply looking at it. In this case, let's assume that we have one of those that we cannot tell by simply looking at it, so we're going to need our instruments. We have a voltmeter across a supply voltage. We're measuring 48 volts. Our supply voltage, as indicated, is 48 volts. So we're good there. As we come over to the fuse, we're measuring 47.999, that's 48 volts. So even though this fuse on this circuit looks good, we're measuring the supply voltage. And we know from the properties of an open circuit that one of them is that we'll measure the supply voltage across an open component or device. This tells us that this fuse must be open. We're measuring the voltage across the switch. Not of much consequence if the fuse is not good. We already have an open circuit. So we can't really gather any additional information, even though we're measuring 0 volts, but there's no current in the circuit. So we're going to get 0 volts anyway. What about parallel circuits? Well, we know the characteristics of a parallel circuit is that the voltage is the same across each parallel branch. That means the voltage from W1 to W2 will be the same voltage from X1 to X2, the same voltage from Y1 to Y2 will be the same voltage from Z1 to Z2. So we put 3 voltmeters, we're measuring the voltage across each of the components, and we're measuring 12 volts. Well, they're in parallel, so we expect to measure 12 volts. Identify the problem, if any, in the circuit below. The first thing that's obvious is that we're measuring virtually 0 volts across each of the components. And we said this is a parallel circuit, so we have a 12 volt supply, so we should be measuring 12 from Z1 to Z2, in other words across R3, 12 volts across R2, and 12 volts across R1. But that is not the case. If we take a closer look at the voltmeter across the fuse, we see we're measuring the supply voltage. So this indicates that this fuse is blown or open. So there is no path for current to flow through these resistors. Hence, we're measuring 0 volts across each of them. Identify, if any, the problem in the circuit below. Well, this goes to show that parallel circuits, troubleshooting parallel circuits, is not always that straightforward. Because when the components are in parallel, even if the resistor 2 is completely removed, you're still measuring 12 volts. Okay? We're measuring 0 volts across the fuse, very little voltage, which is what we expect for a good fuse. So for this circuit, we really cannot determine whether a problem exists or not. All we can say is that the fuse is good, but either of these resistors or components could be open, and we cannot tell by these voltmeter readings. To review the properties of an open circuit, first of all, there is no connection between the 2 points. The resistance across the open is equal to infinite ohms. The voltage across the open points is equal to the supply voltage.